Hi all, I'm Camden. I'm a robotics engineering student at Worcester Polytechnic. I have been working this summer with Dr. Christoph Mertz and Anar Ghosh, and my project at RIS was detecting and tracking accessibility challenges. So what does it mean when we say accessibility challenges? For us, that means anything from someone using a stroller to someone using a wheelchair, right? Anything that could prove a challenge to moving around an environment. So the environment in this case is a bus. So we specifically wanted to try and find instances of people using or wheelchairs or using prams or anything like that, any accessibility challenge, like I said before, so that then we can go back through all of those video clips and say, oh, there's a pattern happening here, right? Like consistently people are challenged by this part of bus engineering, right? So why are we interested in this, right? So public transportation is one, really, really good for the environment, and two, cheaper to use. So we want to encourage people to use public transportation. That's a good thing. And two, buses can actually be really difficult for people with accessibility challenges to use for any number of reasons. Public transport can be a challenge, and we want to remove as many barriers to use as possible. So, like I said before, we're doing that by developing this model so that then the data can be analyzed further. So we started with the mask-to-former instance segmentation model. So instance segmentation is specifically like, if you think about it, a model as identifying wheelchairs, it will find not just a group of wheelchairs, like identify what of the image is wheelchair and what of it is not wheelchair, but it'll find specific wheelchairs and say, okay, there's one here and there's one here, right? So different instances. So, like I said before, if there were multiple wheelchairs in a video, it would identify them both individually. So this mask-to-former model is based on RSCRCNN, and it's trained with COCO. And we used MMDetection to train it. So we started out with using Detection 2, which is also a popular platform for training, but we found that MMDetection worked better for our purposes, and we end up transferring over to that. We trained our model on a combination of simulated and real-world data. So one thing that can be really challenging about this kind of application is that there isn't honestly a lot of real-world data sets, which is why we ended up basically supplementing our data with simulated data from XWorld. So XWorld is a simulator that provides a whole bunch of different kinds of wheelchairs and a whole bunch of images for training models like ours, and we found it useful in this application. So we then used a tracking algorithm to track the people through the images. So one thing that a model isn't going to do super well isn't going to create a comprehensive video clip. And so by tracking the people through the images, you can more accurately say, oh, the model saw the person really well in these frames, and then there were several frames where it didn't see the person just because of occlusion or anything like that. And then it started seeing them again here, but it doesn't recognize them as the same person or anything like that. So you want to really try and track people, right? So we used two different methods to do this just to see, and we started out with the Hungarian algorithm using intersection over union as the metric. So intersection over union is just when you take two bounding boxes and you look at their intersection and then you divide it by their union. And the Hungarian algorithm takes this and says, okay, so with my prior bounding boxes from the images before and my current bounding box, which ones are the closest? So it's a nice way of matching that, basically. However, like I was talking about before, it's not super good at fragmentation. So when there's a long gap, it can sometimes not necessarily recognize that. And it can also not respond as well to when there are multiple tracks of multiple identifications of a person in the single image, right? As you're seeing on the left, it's not doing a super good job of figuring out that those are two bounding boxes on the same person. Versus DeepSORT, which does a really, really nice job of that. Like, you can see that it's just the same exact model, same threshold values, and it's doing a much better job of that. It's also better on identity like fragmentation, so not losing track of which person is corresponding to which, and it's better at not switching identities. Yeah, so that's been my project. Thanks.